Hi, my name is Alan, and I have never done a testimonial before in my life, but I think it was important to do it because of the fantastic company that we found. Sky Heating and Cooling in Portland, Oregon did a fabulous job on the system that we had put in. Travis, who is the owner of the company, came out, looked at our house, and designed a complete system, not just a geothermal heat pump, but also a system that will do a full air exchange in the house, and another heat pump that provides all of our domestic hot water. Now, first of all, let me tell you about Travis. Travis is a guy that, like my wife said, when you meet him, you just want to go up and hug him. He's just a nice guy. But besides that, he is extremely technical, and he actually sits on a board that represents WaterFurnace to provide ideas to WaterFurnace. Now, let me tell you a little about WaterFurnace. 25 years ago, we built this house, and we built it on a shoestring. But the one thing we knew was that whenever possible, we would put the best quality into the systems that we could, because we knew we'd be living here probably the rest of our lives. And I researched for probably a year on different systems. And 25 years ago, the best system out there, hands down, was WaterFurnace, and a geothermal. But we couldn't afford to have the guy that really knew how to put them in. And not knowing the complexities, we had a friend of ours that was just installed regular furnaces, and he installed our water furnace, and quite frankly, did a very, very poor job. The water furnace worked great. It provided all the heating and cooling for 25 years, and not once did we ever have to use auxiliary heat. Now, one of the reasons for that is we have an open loop system. Now, what open loop means is that we're using our well water to go through the water furnace. It extracts energy out of the water and then uses to heat or cool our house. And our water temperature happens to be about 50 degrees, which is ideal for a water pump, for a geothermal water pump. So anyway, we signed a contract with Travis, and he climbed into the house with everybody else, and we started looking at what we were going to do, and we elected to have the old water furnace, which, by the way, was still working fine. But after 25 years, it just seemed like it needed to be replaced. And so we went ahead and had that replaced, pulled out, and completely gutted all of the ductwork so we would have fresh, clean ductwork. And I'm actually going to be posting on YouTube a time-lapse video of that installation. But let me just say that what we ended up with was a Series 7 water furnace, which has a COP, or coefficient of performance, of 5.9. Our old one was 3.8. What that means is for every watt of energy that you use, it produces 5.9 times more energy in the line of heating. Now stop and think about that. There's no other system out there that I know of, well, other than a heat pump, but nothing can come close to the 5.9 geothermal. And there's a whole lot of other technical reasons to go with geothermal. One is you get a lot longer lifespan out of it because it's working with a constant temperature. Now, The Series 7 is just a remarkable heat pump. It has a variable compressor and a variable speed fan on it. And because we're on an open loop system, it has a variable valve for the amount of water that it uses. So if the house is up to temperature and it's just kind of idling along, or maybe even off, obviously if it's off, it shuts off the water, doesn't consume any. But if one of the rooms drop down to a particular temperature, it will then slowly open that valve up to just the right amount of water. The compressor comes up to the proper speed to provide the amount of heating or cooling that's necessary, as does the fan. Now in our case, we went with a 3-zone system. The living room, dining room area, which I'm in now, is zone 2 because we don't really use it that much. And we generally have it off. We have an upstairs bedroom that gets hot all the time. That's our zone 3, and we generally have that, like right now, in the cooling mode. Downstairs, our family room is zone 1, and that can either heat or cool depending on the type of equipment we were running. That's where our big screen TV is, all of our computers, that type of thing. And because we've built a very energy efficient house, we kind of joke about the fact that we can heat our family room with the electronics. The downside to that is the other rooms suffer because that's also where the thermostat is. So let me stop at that point, and what I'm going to do is take you on a little tour of what we had installed and maybe do some little education along the line for those of you that are not familiar with the geothermal. Okay, this is the main thermostat for the Series 7, and from this you can control any of the zones. Now, for example, you can see there on zone 1 we have cooling set for 72. It's early in the morning here, so it's 67 degrees, and I could have put it in auto mode where it would heat or cool to keep it at the same temperature, but I elect to like cooler homes to have the air conditioning just on during the summer. Now, zone 2 is off, as you can tell by these, and then zone 3, which is the bedroom, is set for 69 degrees. Now, this is the only zone where I can, or the only thermostat. This is the master thermostat. It's the only one I can use to control all 3 zones from one location. However, I understand that WaterFurnace is working on a new system that will allow this type of thermostat to be used in multiple locations, and they're also going to be putting the thermostat so that it's on the internet, and you'll be able to actually see what's going on in your house while you're traveling. For us, that's extremely important because we're constantly checking on our house while we're traveling to see that everything's okay. Okay, now let me show you one of the other thermostats. Okay, this is one of the other zone thermostats, and you can control, this is the one in the living room, and you can control the living room zone from here, but only the living room zone. Okay, this is the Series 7, and I'll run through it real quickly. On the end is our hot water heater, and it looks so much nicer down here than it did before. If you can imagine this whole thing clogged with air ducts. In fact, I'll try and get a photograph and insert it, because I did do a before and after photograph. Okay, this is the Series 7 that we have installed. Again, it's a 4-ton unit, and basically water comes in, and that's in the red pipe. And let me start at the beginning here. Okay, let me zoom in here a little bit. And so the water's coming in, and then it goes to that little device there, which is a modulating water valve. Okay, for some reason my camera's not focusing, but anyway, that's a modulating water valve. What that does is it supplies variable amounts of water to the heat pump. Now this actually communicates with the heat pump to tell it how much water it needs. Now it runs along, it comes down that red pipe and into the water furnace. And then from the water furnace, it extracts all of the heat that it can from the water. Again, COP of 5.9. And then the output comes up, and they put a valve on it for maintenance, and then back down, and it combines into the outflow for our other heat pump. And again, with the WaterFurnace Series 7, a variable compressor, variable fan, you don't hear anything because it's normally just idling along. Now, Travis, he puts in what he figures is the best. In this case, he coupled the water furnace with a Train electronic air filter. Our last air filter that we had from, and I'll say it, Honeywell, sucked. In fact, it actually plugged up some of the intakes for the water furnace. Now, if we move over a little bit, that's the zone controller that again communicates with the Series 7 to decide which zones need to be open and closed. And it has dampers that it will open depending on the needs for the heating and cooling. Okay, so that's the Series 7. Now, one of the nice things is that Travis allowed me to do all the plumbing and wiring, which saved us some money. And because I'm a homeowner in Oregon, I can do my own electrical and plumbing. So there's the two sub panels that I ran with two disconnects. And I used the circuit for the auxiliary heat, which we never used, to fire off the WaterFurnace 7, Series 7. Then on the right-hand side is the old circuit for the actual heat pump from the old water furnace, and we're using it now to heat our hot water. This is an Envision water-to-water system. Now in this particular case, what this furnace does, or this heat pump, it extracts, it runs at 2 gallons per minute, and it extracts the heat from the water, and it's a heat only in this particular case, extracts the heat, and then it puts it into 2 tanks. This is one tank, it's 50-gallon lowboy, that's connected in series with our primary tank, which is upstairs. So we have 120 gallons of hot water. Now, you can also use them as a preheater, but we elected to have all of our hot water produced by this. It's a little cooler, it's 120 degrees rather than the 140, but it's definitely enough hot water that you don't notice any difference as far as temperature-wise goes. Now, right there is it's currently at 118 degrees, and it's set up so that at 116 it will fire off and heat it up to 120. Now maybe I'm going too deep in the weeds here, but it's just a fascinating system. Every I think it's every 4 minutes, this fires up a little tiny circulation pump that stirs the tanks, and it takes a reading in the tank, and if it's 116 or lower, then it fires off the whole system to heat the water back up to 120. Now, above it is the main pump that pumps water. So once it has decided that it needs to heat the water up, it fires off the heat pump, and then it needs a bigger pump to circulate the water. So this gets water from the tank, runs it through the water furnace, and then into the 2 tanks, and then back again. And this has just a on-off valve instead of the modulating valve. It just turns water on and off, and it has a 2 gallon per minute restrictor on it. So that works out pretty cool. And I've got a diagram that shows exactly how this works, and I'll show you that in a minute. Then they also installed an expansion tank just as a precaution to prevent water hammering. This is designed to eliminate the hammering of all of a sudden turning water on and off so quickly.
Okay, as promised, this is the diagram for our hot water tank. And this basically is what we had before, just our domestic hot water tank. Now, this is the cold coming in from our well, and it branches off, comes down into the heat pump, that Envision heat only heat pump, except for heat only. It can do heating or cooling. In our case, we have it heat only. And then it just comes up, extracts all of the heat that it wants, or that it possibly can, and then there's a solenoid, of course, that is opened, and it goes into the drainage line. Okay, now on the hot water tank side, you have the water coming out of the hot water that after it's been extracted comes out of the heat pump, goes into what used to be the drain for our lowboy hot water tank, 50 gallon. So it's pumping hot water into that, and then it continues on up and pulls the hottest water from this tank, goes up to the top, and then dumps it into the coldest portion. And of course, you know, hot water rises, so it will form a thermal layer in this tank. Then we pull the coolest water off the bottom of the primary tank through a water filter, mainly just to catch any sediments or crystals or anything that might form on the bottom of the tank, and then through the pump, which is providing the energy to get the water through the system. And remember, this only runs when it's actually heating or cooling, and then back into the heat pump. Now, one of the other things that we did was they put in the expansion tank to prevent hammering, but we also installed a check valve so that when there's a demand on the cold water side from other parts of the house, that it won't suck in hot water back through the system. So that check valve makes sure that this is a closed system, except for when it needs water from like somebody taking a shower or whatever. It will bring in the cold water and replenish the water supply. So it's a very well thought out system.
Okay, I'm not going to climb all the way back there, but that's the life breath, and what it does is it brings in air from the outside and it mixes the outgoing air to kind of modulate the temperature differences. It's kind of like a radiator in a car, and the airs never mingle but it basically brings air in, warms up the air, pumps in filtered, warmer or cooler air, and then exhausts out the other air. So it's a kind of a closed loop system that gives you fresh air. I think it's set for 3 complete air changes per day. And we've really noticed a difference. I've actually woke up 2 days in a row now. We've had the system in 2 days, or 3 days, and woke up 2 days in a row without a headache and no allergies. So between the Series Water 7 and this device, it's really made a huge difference. Okay, there's one very important part that I forgot to mention, and that is with an open loop system, you have excess water being used by the pump, in our case the 2 heat pumps, that you need to do something with. In our case, for 25 years, we just used a gravity feed type of system to run sprinklers. So every time the heat pump would come on, it would irrigate our couple acres of yard. And so we would be using that water anyway. Now with the new Series 7, there's going to be quite a bit less water consumed. So my new strategy is I'm going to get a series of water tanks, in the case the totes, the plastic totes, and I plan on having about 1,000 gallon capacity that these pumps will, the water used by the heat pumps will go into the containers and will be filled. It will then trigger a valve and then drain the tanks out in one fell swoop. And if I need to, I can put a little booster pump on it so I can run a different type of sprinkler or actually irrigate uphill from areas that I've normally not been able to irrigate because of the gravity feed. So that is something that I wanted to mention. During the winter, live in Oregon. We have tons of water, lots of drainage. I just dump the water into our drainage system. Another thing that I've been looking at is by going with a little bit larger volume of tanks, putting together and partnering with our local fire department, because we are rural out here, to supply emergency water in case of fire for us or anybody else. They will be able to tap into our storage tanks. So that's the plan, and we've got everything implemented up to the point of the water coming out, and that's going to be the next project for the next couple of months, is to get a series of water containers and hook them together in series for various uses.